So a lovely evening again. We are straight away going to discuss trigonometry, but it's mostly going to be two parts that we're going to deal with. We're going to deal with reduction formulae and trig identities. Those are the two main things that I'm going to show you how to do. And like I said, if you know trig identities, if you know reduction formulae, all other parts of trig should be definitely easy to do. Okay, so before we start though, right, since our session one is about reduction formulae, let's start with some of the background knowledge on trigonometry. Or rather, let's call them some tools that we usually going to use when we're working with problems in trig. The first tool that you can remember is what SOHCAHTOA, ne? SOHCAHTOA. And by the way, trig, remember, has around 6 to 5 parts, so they are all linked and interconnected. So these are our ratios, right? And again, remember, we're going to need our cast diagram. And let's remember that this is called the first quadrant, and then this one here is called the second quadrant. The second quadrant is between the second quadrant is between 90 degrees and 180 degrees. Then we have 0 degrees. Then so this is also 360 degrees, right? And then 270 degrees. Okay, and then this is the third quadrant here. Third quadrant, and then this is the fourth quadrant. And then this is the x-axis, this is the y-axis, and then we know that this is the positive x-axis, this is the negative one, 0 would be in the middle. And then right, that is the first thing we need to know. So the names of the quadrants are very, very important. Please let's remember, this is the first quadrant, this is the second quadrant, this is the second quadrant, this is the third quadrant, right, and then this is the fourth quadrant. We move anti-clockwise. Those will be the positive angles. Okay, all right. First quadrant, second quadrant, third quadrant, fourth quadrant. First quadrant, second quadrant, third quadrant, fourth quadrant. First quadrant, second quadrant, third quadrant, fourth quadrant. How about Minier? We do know these quadrants. Hey, this is trig Ngwanaka. You must know the quadrants, especially now that we're going to talk about reduction formulae. You must know the quadrants. Okay, then now what do we have in the first quadrant? Let's remember that in the first quadrant, this is where we find, we can say this is where we find 90 degrees minus theta. This is where we also find just theta. This is also where we find 360 degrees plus theta, right? And then in this one, this is where we find 90 degrees plus theta, because it's 90 plus a certain angle. In this quadrant, if I were to draw an arm, that arm here would have an angle that is 90 degrees plus a certain angle. So that is why this is the quadrant for 90 plus theta. and then this is 180 degrees minus theta, and then this is 180. Here we find, in the third quadrant, we find 180 degrees plus theta, and then in the fourth quadrant we find 360 degrees minus theta. Great stuff. When you simplify it, you can say that in this quadrant you just have theta. You can say in here you just have theta, and then in there you just have 180 minus when you simplify it. So you can just say here you have theta. But not forgetting, right? Not forgetting that we also find 90 minus theta. Not forgetting that we also find 360 degrees plus theta in the first quadrant. Then in here it's 90 degrees plus theta. All right. Are we all clear here? Right. I hope that is clear. So now, let's say, like I want to maybe just condense it a bit, right? So what I will do, guys, is that I will try to have these angles maybe written in a much bit smaller way, right? Forgive me for that, because we have some stuff we need to write in there. So let me just say in the first quadrant, let me just write the theta here, right? And let me just write the 180 degrees minus theta here, okay? Then here the 180 degrees plus theta here. Oh, by the way, what they usually do, right? I've seen one of my colleagues do this. He says here, he just put a plus theta here, and then here you put a minus theta to remind him that this is 180 plus theta in this quadrant, 180 minus theta in this quadrant. Or some people do this. Some people write the 180 here. They write the 180 degrees here, exactly here in the middle, and then here they just say minus theta, and then here they just say plus theta. Okay, then same thing with the 360, right? So what they do is that they write the 360 degrees here, and then they say on top it's plus theta, and then on the bottom it's minus theta, but not forgetting that there's also a 0 degrees, right? So this is what they usually do, and it's usually sufficient because we're only using 180 minus theta, 180 plus theta, 360 plus theta, 360 minus theta, you see. So it's very much sufficient. Now if you grab your calculator, right, and you put sine, I want you to put sine 2 degrees. Can anyone put sine 2 degrees in their calculator and tell me the answer that they get?
Don't 0.3.
Oh yes, it's 0. Can you maybe tell me whether the answer is positive or negative?
Positive.
It's positive. Okay. Can we try sine 1 degree?
Positive.
Positive. Can you try sine 88 degrees?
Two.
Positive. All right, can we try sine 89 degrees? Is it positive or negative?
Two.
It's still positive.
Positive.
Yes.
It's like
Yes,
you're
so
just
it's
saying
positive.
tiv. Yeah. Oh, you're saying tiv. But in my head, I'm like positive. Can't you are just saying tiv? I see what you are doing there. Okay, can we try maybe sine 91 degrees?
Positive.
Wow. What about sine 179 degrees?
Positive.
Okay, let's try sine 181 degrees.
Negative.
Negative. Wow. And let's say sine 269 degrees.
Negative.
Okay, and then let's say sine 300 degrees.
Negative.
Wow. And then let's say sine 359 degrees. Let me be writing them here. Negative. Oh, sorry. This one you are still to tell me.
It's negative.
It's negative. Oh, I think this one was negative. And this one was positive. 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 And then negative. Okay. So guys, using this, can you tell me in which quadrants is sine positive between quadrant 1, quadrant 2, quadrant 3, and quadrant 4?
Quadrant 1 and quadrant 2. 1 and 2.
Quadrant 1 and 2. So we are saying in this quadrant, sine is positive. In this quadrant, sine is also positive, sine theta. But in this quadrant, when we started to say sine 181, which means like we're saying in this quadrant, right? We started to find negative numbers. So in this quadrant here, sine is negative, and then in this one, sine is also negative. Good people, if you do a similar exercise with tan and cos, you're going to find out that here cos is also positive for all angles that are between 0 and 90 degrees, and then tan is also positive for all angles that are between 0 and 90. And then if you try the angles that are between 90 and 180, you are going to find that cos gives you a negative answer, and then you're going to find that tan also gives you a what? A negative answer. And then if you do a similar exercise in here, you're going to find that tan is the only one that is going to come out as positive. But when you try cos and sine, you're going to always get negative answers. And then if you try a similar exercise in here, you're going to find that cos is the only one that is going to be positive, and then the rest of them are going to be negative. So what we usually then do is that we zoom in, right? We zoom into this part, to the one that is positive in that quadrant. We zoom into the one that is positive in that quadrant, and then we simply say in the first quadrant, all of them, in the first quadrant, we say all of them are positive. In this quadrant, we say it's only sine which is positive. In this one, we say it's only tangent which is positive. In this one, it's only cos which is negative. So usually say sine, tan, and then cos. So this is then shortened, right? Now what your teacher taught you is that now you can just simply say in this first one, right, you can say, you can call it A to remind you that all of them are going to be positive. If you put all angles that are between 0 and 90, for all of the ratios, you're going to get positive answers. So the A would be to indicate that all of them are positive in the first quadrant. In the second quadrant, we put S to remind us that it's only sine which is positive in the second quadrant. And then the third quadrant, it's only tan which is positive, the rest are negative. And then in the fourth quadrant, it's only cos which is positive, the rest are negative. So that is where the term, the cast diagram, comes from. It comes from us trying to find a way to remember which ratios are positive or negative in each of the quadrants. I personally also do not like just to put this table out, the Cartesian plane there, and just start writing positive, positive, negative, negative. We must understand why are we doing that. This is because when we put in our calculator all angles that are between 0 and 90 degrees on these ratios, we get positive answers. That is why we say all of them are positive. If you take these ratios, for example, let's look at angles that are between 270 and 360. You can take 300 degrees. Put cos 300 degrees in the calculator, sine 300 degrees in a calculator, and then tan 300 degrees in your calculator. Now I want you to tell me, for cos, do you get a positive or a negative answer?
Positive.
Positive. And then for sine, do you get a positive or a negative answer?
Negative.
Negative. And then tan?
Negative.
Negative. So you can see that it's only cos that is going to give you a positive answer. That is why we say in here, we put a C to remind us that it's only cos that is positive. I know that this is revision, of course, so we already know these things. I trust you guys. So right, but if you did not, then it's a good way to learn. Now that we have talked about our cast diagram, okay, for this one we won't really need SOHCAHTOA for the questions we're going to do, but we are going to need the cast, what you call the cast diagram. We are going to need the cast diagram. So let me try to then select this and then talk about the ones that I left. Right. So another thing that I want to come to, right, is that I'm going to bring back the fact that in here you have theta. Let me try a different one. That in here you have theta, in here you have 360 degree, you have 180 degrees minus theta, and then in here you have 180 degrees plus theta, and then in here you have 360 degrees minus theta. Right. So another thing we need to familiarize ourselves with is why are we having these 180 minus theta, 180 plus theta, 360 minus, right? And what do we call those? What are those things there, right? Let's remember that those are what we call our reduction formulae, right? Reduction formula. And how do they work? Why is it 180 minus? What's going on? The standard ones that we work with in grade 12, grade 10, and grade 11 is 180 plus or minus theta, and then 360 degrees plus or minus theta, and then 90 degrees plus or minus theta. Obviously, IEB students, they also do 270 degrees plus or minus theta. But for us, we don't really use 270 plus or minus theta. We use only these three. which makes our life easy. So how do they work? They are there to do one simple task. It is to split a number. Okay, they are there to split a number. Let me give you an example. Let's say you have 5. 5, I can rewrite 5 as 1 plus 4, right? I can also write 5 as 2 plus 3, right? I can also write 5 as 5 over 2 plus 5 over 2. Right? And then I can also write 5 as 3 over 2 plus 7 over 2. Right? These are so many different ways of writing 5, isn't it? Now that 5 can be split into many different addition equations, right? I can also, let me show you, I can also write 5 as 7 minus 2. Isn't 7 minus 2 5? It's still 5. I can also say 5 is 10 minus 5. I can also write 5 as 16 minus 11. I can also say 5 is 26 minus 21. Good people, I can flex all I want about how my mental math is good, but that is not the whole point. The point is that there are so many ways of expressing something, especially a number. There are so many ways of expressing it in terms of addition and then in terms of subtraction. Right? Same thing with angles. Now you know the definition of an angle coming from where? Coming from Euclidean geometry. So when we're dealing with angles, we also have many ways in which we can express them. For example, if I have let's say 150 degrees, you see 150 degrees, I can write it as 75 degrees plus 75 degrees. You can check it here. Agree, you have a calculator, it will give you 150. I can also write 150 degrees as 200 degrees minus 50 degrees. True, right? And then I can also write 150 degrees as 25 degrees plus 125 degrees. It's gonna give me 150. You can try it with your calculator, okay? It's going to give you 150. So this tells you that there are so many ways of expressing an angle. Since there are so many ways of expressing an angle, to say in terms of its addition and subtraction respectively, to say if you add it or subtract different numbers, they can give you this angle. There are infinite number of ways of doing it. Good people, you see, if you wanted to talk about expressions for 150, we can start now until you guys have children and your children have children and those children have other children. There are so many numbers that we can put together and that can give us 150, right? So because of that, we centralize the system. You understand me? We centralize it. In what way, or in which way do we centralize the system? We say, don't go around expressing an angle however you like, because someone can just wake up and say 150 75 plus 75. Don't express it however you like. Rather, express it in some certain way on certain occasions. That's English, right? So we are saying there are so many ways of how you can express these angles, but we need a centralized system or a common way of expressing them. we need a certain guide. You understand me? You need a certain guide to what? To split a number so that every one of us can do the same thing. Because if we allowed you to split, I said split. J, guys, that's split, eh? Hi. That's split. So there are many ways of writing. Another way, 150 degrees. We can say 150 degrees is 300 degrees minus 150 degrees. You see, this is me flexing. Another one can come and say, but 150 degrees, why are you thinking far? It's actually 149 degrees plus 1 degree. And then Mr. Liama says, no, gents, you guys are complicating things. 150 degrees, it is simply 100 degrees plus 50 degrees. You see, we have so many ways in which we can write it, only using addition and subtraction. Please note, only using addition and subtraction. So we need a centralized way of doing it so that we can all say the same thing. That is why we have the reduction formulae. So these formulae are what we use to reduce any angle that we have. And they are called formulae for a reason. It's actually a formula. For example, that 180 minus theta, it's actually a formula. But how do we use the formula? That is the key part where many of us get lost. How do we use the formula? How do I use 180 degrees minus theta? How do I simply use it? Well, it's very much simple. You see, in trigonometry, you need to learn to be asking yourself questions. If you don't ask yourself questions in trigonometry, it's going to be very, very difficult for you to solve problems. You must always ask yourself questions. Talk to yourself. I myself, when I mastered trig, people used to say I'm crazy because I was talking to myself. But good people, sometimes you just need to sacrifice so that you get what you want. So you need to ask yourself questions a lot. That is another thing, right? Ask yourself questions a lot when you're dealing with trig. If you're not asking yourself questions, it might be a bit challenging. So what type of questions do you ask yourself? The only question that I need us guys to practice asking ourselves, it's only one question. You see, if you can always use that question, we are done with this. Recognize manually. GG. Okay. So the only question that you are going to ask yourself for this section all the time, it's only one question that I need us to remember. I'm going to write it here, and then I'm going to need someone to read it for us. Sometimes maybe I might be saying this is the question, and then people must ask themselves this, but maybe I'm actually thinking or saying a different thing, right? I'm still here, guys. Here is the question that I want you to ask yourself. Can someone please read it for me?
Between which two angles does this one lie?
Usually, ma'am, you need to read it slow. Slow and nice and easy. Let's go.
Between which two angles does this one lie?
Do you understand the question, ma'am?
Slightly.
Slightly. Good. I knew that you are going to understand it slightly. That is why I was researching and researching. Then I then learned that actually this question you can also ask yourself in French, right? And then I found the very same question in French. Let me write it for you here. So in French, right, no offense to the French speakers, but in French, right, it you ask yourself this way. In which quadrant? Oh, yeah, English, eh? Oh, French. Jo. Okay, can someone read that for us?
In which quadrant on the Cartesian plane does this angle belong in?
Wow, can you say that one more time, ma'am?
In which quadrant on the Cartesian plane does this angle belong in?
Wow. Yeah, exactly. In which quadrant on the Cartesian plane does this angle belong in? That is the only question you need to ask yourself. If you are able to ask yourself this question every time you are doing these problems, trust me, your life would be very, very easy. So we must always locate which quadrant does this angle that we are presented with belong in. Let's talk numbers. Sometimes words can be very, very, troublesome. Let's talk numbers. When we talk numbers, right, here you are presented with 150 degrees. You still ask yourself this question: in which quadrant does this angle belong in? Or you can say, between which two numbers is this angle? You can see, since it's 50 degrees, 150 is definitely between 90 degrees and 180. Why? Because 150 is greater than 90 degrees. 150 is bigger than 90 degrees. However, it is smaller than 180 degrees. Okay, so because of this, we can definitely say that 150 degrees belongs in the second quadrant. And now, because it belongs in the second quadrant, we remember now the formula in the second quadrant says that 180 degrees minus theta. Now you then say, okay, for me to reduce 150, I must say 180 degrees minus a certain angle. Now the question is, which angle must I subtract? In most cases, I know you can do it mentally. Yes, you can do it mentally. But if you feel like sometimes you might get it wrong, or a method that you're always going to use which gives you the correct answer all the time, is to say 180 degrees minus theta is equal to 150 degrees. This is for my students who I know that they struggle with mental maths. So you then say, I will take 150 to this side, right? 150 to this side, so that it's minus, and then minus theta to the other side, which will be positive. Now when you say 180 minus 150, you get your theta as 30 degrees. Therefore 150 degrees can now be written as 180 degrees minus 30 degrees. In this way, yes, 150 can be made of many other Remember, Kira, we talked about them. Both 300 plus minus 150, but 100 plus 50, no? There are so many ways. However, the standard way that we want you to be using would be this one. So for us to use the standard way, that is why we use the reduction formulas. So each angle can always be expressed in terms of one of these, right? So when do we use which depends on the size of the angle. Usually, if the angle is between 270 and 360, definitely you'll use this reduction formula, 360 minus theta. If the angle is above 360, you're going to use the reduction formula 360 plus theta. If the angle is between 180 and 270, you are going to use 180 plus theta. If the angle is below 90 degrees, you understand me? If the angle is below 90 degrees, such as 60 degrees, such as 50 degrees, then it's already reduced, because usually the main goal of reducing these angles is to get an acute angle, which is an angle between 0 and 90. So usually for these ones, they are already reduced, but it is also helpful sometimes to reduce them using the reduction formula 90 plus or minus theta, so that you can play around with what we call correlations. Okay, so I hope that is clear, guys. I know that you know these things, I know, but then it's just very important to understand why we are doing things. With that being said, right, let's then remember that if you have sine 200 degrees, you ask yourself, 200 degrees is in which quadrant? Well, 200 is bigger than 180, but it is smaller than 270. So actually we can rewrite this as sine, and then we open a bracket, and then we say 180 degrees plus theta, right? But if you don't know what angle to add there so that you get 200, usually I just say, you say 180 plus, then you open your bracket, then you find that angle that you must put there. So how do you find the angle? Remember, you can say 180 plus theta is equal to 200, then you solve for the theta, which would be 200 minus 180, so that means that theta would be 20 degrees. Then that is the one you shall put there. Okay, so let's remember that. And then if it so happens that you have sine 90 degrees, let's say minus theta, let's remember that these ones that will be having 90 minus, they are our core ratios. So if you had sine, it would change to cos, and then if you had cos, it would change to what? It would change to sine. Then let's remember that if I have sine 90 degrees plus theta, yes, it is in this quadrant here. It is in the second quadrant. However, because it's a 90 plus, right, sine will change to cos theta. And then if it is cos 90 degrees plus theta, right, cos would change to sine. However, it should be negative. Why? Because cos is negative in that quadrant. If you can remember, cos is negative in that quadrant. So that is why your answer must have what? Your answer must have a negative. Right, so let's always remember that these are our core ratios. Core ratios. Enough talking, let's get to business. Oh, by the way, also try to remember your reduction formulae. Remember that your reduction formulae now is this one, but remember that in grade 12 now we're introduced to compound angles. Let's do it this way. If it so happens, right, that you are given angles between 0 and 360, we use the reduction formula to reduce them. But usually, if you are given angles that are less than 90, let's remember that somewhere, somehow, we would have to use our co-ratios. Right, we would have to use our co-ratios. Right. And then when do we use these ones now? Okay. Yeah, when do we use compound angles? Like, let's say cos A plus B would be equal to cos A cos B minus sine A sine B. When do I know that I have to use these? I have to express the angle as a compound angle. Well, you do that if it happens that maybe you want to prove something, or already what you are given is having more than two angles. Like if I give you cos x minus 10 degrees and then I say sine y plus 20 degrees, then I say minus sine x minus 10 degrees, and then I say times cos a certain angle. So usually in an expanded version like this, let's do remember this one is a giveaway that we must remember our compound angle formulas. Okay, let's have the first one, guys. So this is what we have for the first one, right? We need to simplify to a single trigonometric ratio of x. What do we do, right? The first thing, right, since we have cos squared 225 degrees, good people, remember, we ask ourselves this question. What do we ask ourselves? Does anyone still remember? Anyone?
In which quadrant the Cartesian plane has this angle to 1?
In which quadrant does the angle lie? Now, obviously, 225 degrees, if you can remember our cast diagram, since we're at 0 here, 90, 180, and 270, and 360, right? Let's remember, 225, it is bigger than 180. But you can't say 225 is bigger than 270. 225 is below 270. So that means we are actually talking about this quadrant. Which quadrant is this? We're talking about the third quadrant. Good people, I don't know, when you start working with these questions, I don't want you to stress yourself. Before you attempt the question, I need you to identify the quadrants first. That is the method that you and I are going to use for the rest of this session. You don't answer the question first. You identify the quadrant first and you write it with a pencil, right? So for example, this one already we can identify it's in the third. Write it here to say it's in the third quadrant. Don't solve the question yet, identify the quadrant. Then this one is tan 180 plus. It's already a giveaway, this one, because it's not an angle. Already they give you that it's 180 plus, of which you know 180 plus theta is also in the third quadrant. So you would simply say third. And by the way, good people, we usually want to write an angle first and then a letter afterwards. So if you are given in such a way that a letter is first, you need to make sure that the angle starts first. Either 180, 90 or 360 must start first. Now 90 plus x, let's remember that this is in the what? In the second quadrant, because 90 plus, remember, it is in this quadrant. And then sine minus x, all negative angles, I need you to take them as being in the fourth quadrant. So this one you would write that it is in the what? The fourth quadrant. Good. After identifying them, this is then what you do, right? You then say those that have squared, you deal with the squared first, okay? Those that have squared, you are going to rewrite it but put all of them, say all squared. So for example, this first one, you are going to rewrite it as cos 225 degrees. Then after that you put the squared on top. Are we clear? Then here you have your tan 180 degrees plus x, and then you have your cos 90 degrees plus x, and then you divide that by by sine negative x. Right. Now what is the next step? Bodmer says you must work with the one in the bracket first. So the one in the bracket is this one. We must work on it first. So when we work on it, what do we say? We say 225. Remember, we already identified that it is in the third quadrant. So now we are not going to think a lot. We are simply going to say, since 225 is in the third quadrant, you're going to write it as cos, then you say 180 degrees, then you say plus, because it is in the third quadrant, and then you say all squared. But which angle must I add for me to get 225? I believe that should be what? 45 degrees, right? Yeah. Then there's nothing stopping you on working with others already and simplifying them. Nothing is stopping you. So since tan 180 plus, we already identified that it is in the third quadrant. The next question we're going to ask ourselves is that, is tan positive or negative in that quadrant? So we can see that tan is negative in that quadrant, in the third quadrant. So because of that, oh sorry, it's positive, right? Cast the diagram. It's positive. Tan is positive in this third quadrant. So we're going to write it as positive tan. Then we just take this x, right? So we say tan x. And then here, we already know that it is in the second quadrant. However, because it's 90 plus, remember it's a core ratio. So cos must change to what? Cos must change to sine, right? So that cos would change to what? To sine. However, because it is in the second quadrant, remember cos is negative in that quadrant. So even though it's going to change to sine, but that sine must be negative, right? And then here, remember we said we take these as in the they are in the fourth quadrant. You ask yourself, is sine positive or negative in that quadrant? In the fourth quadrant, it's only cos that is positive. So it means sine should be negative. And please use brackets. Please use brackets. Then now that we have these, usually you're going to find patterns that actually this one can cancel that one, isn't it? And now that they cancelled, what you then do is that you say, here we are continuing to work, right? You're now going to say, cos 180 plus, in which quadrant is that? We already know that it is in the third one. Is cos positive or negative there? We know that it's negative. So you would say negative cos 45 degrees, then you say all squared, then multiplied by what? By tan x. These two are already gone. Then you continue, right? You continue. In this case, right? Because it's 45 and it's a special angle, let's remember that our special angles are essentially 0 degrees, 0 degrees, 30 degrees, 60 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. All right, let's remember that it's those there. Now if you say cos 45, right, cos 45, obviously you know that you have to use your what, because it's a special angle, right? Remember we have to use our special angles diagram. Remember it's two diagrams, isn't it? Remember it's this, oh, we already have the triangles. Remember it's this triangle, okay? Then it's the other triangle. It's two of them. then if you can remember, I always say, if you draw them like this in your exam, if you draw them like this, then I just need you to remember 1, 2, and 3. Then I also need you to remember what can 1, and then 1 plus 1 is what? It's 2. So you just need to remember those codes. It's secret codes between you and I. 1, 2, 3, 1, 1, 2. 1, 1, 2 is for 45 degrees. So you know that the other one is going to be for 30, 60, and 90. Okay. So 1, 1, 2, how does it work? You always you start from the bottom, right? You always start from the bottom. Your 1 would be here, and then your other 1 would be here, and then your 2 would be here. So that is your 1, 1, 2 triangle, related to what? To 45 degrees. By now I know it must be in our heads. And then the other one, usually you can write it, you see on your diagram, on your answer sheet at the back they say extra space. You can write it there, or you can write it on the on your answer script, which it's still fine as long as you can remember them. But we say 1, 1, 2, and then on the last number that we call, we always put a root. Okay, on the last number we always put a root. So that's what. So we say 1, 1, 2, and then we put a root sign. Don't forget the root sign. It's not a code if you don't have the root sign. Then the next one here, remember, you're going to say 1. Do you see that you had a 2 here? So you must also have a 2 here. However, this side now you're going to put a 3 and then put a root there. So these triangles are going to be similar in such that you would say 1, 1, and then a 2. Then you say 1, 2. The 2 and the 1 have a similar position, and then on the third one here you just changing the 1 to root 3. If you want to think about it, 1 plus 1 is 2, 1 plus 2 is 3, and then where you say the answer, that's where you put the root. But let's remember the 2 will be here and the likes. So because here there is a 3, I should remember that on top I must put a 30 degrees, and then on the bottom I should put a 60 degrees. Those are our triangles there. Alright, so now cos 45, right? So as we were saying, right, these are the two triangles, the 1, 1, 2 triangle and the 1, 2, 3 triangle. 1, 2, 3 is about 30 and 60. The 1, 1, 2 triangle is about 45. Now let's remember that when you write them, you say 1, 1, 2, and then you put a root, because 1 plus 1 is 2. And then the 1, 2, 3 triangle, because 1 plus 2 is 3. And then we put a root on the answer, that root 3. Then 2 and 1 are on similar positions. If we can have that, you'll always be fine. So cos 45, let's remember that SOHCAHTOA, right? So cos is the adjacent side, which is this side, the adjacent side, over the hypotenuse, which is the root of 2. So you would say that is 1 over the root of 2. Then you say all squared. Then you have times what? Tan x. Then, good people, this one here, you are allowed to put it in your calculator, right? Yes, we know the instruction says without using a calculator, but always after substituting using the triangles, you can put that straight away into your calculator. So if you do that, I believe you must get half, right? So that will be half tan x. So in that way, you have expressed this in terms of a ratio, a single trigonometric ratio of x. Even though there is a number, the fact that the ratio is only 1, you are done. Okay? Even if you have a number, the fact that the ratio is only 1, which is tan, then you are done. Alright, so just to recap, I'm going to list all the methods that we're going to use. Very, very simple methods. Number one, remember, identify the quadrants first, right? Then after identifying the quadrant, what do? You then if there are any squared, obviously if there is any squared, then use bigger brackets or use brackets, right? If you have any squared, use brackets. And then after that, simplify using the quadrants, then you're good. Let's look at the next one. Here we are, right? Yeah. The problem seems like we have complex numbers, but it's not. Remember what I said. The first thing, you identify the quadrants. So 90 minus which quadrant? Which quadrant is that? Can anyone maybe try to tell me? Just try.
The first one.
That is the first quadrant, because that's 90 minus. Okay. And then what about theta? It's already in the first, that one, it's already good. And then this one, which quadrant, guys?
Third quadrant.
The third one. Nice stuff. So this would be,
Excuse me, sir.
in the third. Yes?
Sine theta, can't you say it's in the second quadrant?
Sine theta.
The one you said is in the first quadrant, yes.
Yes, why are we not taking the is in the second? If you want to say it's in the second, then you would be looking at that theta there as already a simplified version of sine 180 degrees minus theta, which would be correct. If you look at it as a simplified version of sine 180 minus, then it's correct. Or you can simply say, because it's only theta, it's in the first quadrant, just like we indicated that theta only is in the first quadrant. Right. I hope that is clear. And then perfect. And then 720 degrees, right? Let's remember that this is an angle that is bigger than 360. However, we still do take it as if it's in the first quadrant. Okay, that is okay. Then we can go to the solving part. Do we have any squared? Oh yes, we have a squared at the bottom. So that squared there. Now, for me not to forget, I'd rather just rewrite everything, but that squared already deal with it. So I'd rather repeat everything, is fine. Then that squared, remember I write the ratio exactly the way it is, 180 plus theta. And then I put the squared outside. Okay, then I have cos 720 degrees plus theta. I'd rather do that first so that I don't forget. Right. And then now, for cos 90 minus theta, remember, the moment it's 90 minus, it's a co-ratio. That means that cos must change to what? To sine. And it will be positive because in the first quadrant, all of them are positive. So you're going to have sine, what? Sine 2 theta. And then you have a sine theta here, divide. Now inside the brackets, you have sine 180 plus theta. You already identified that it is in the third quadrant. And then now in the third quadrant, if you can remember, right, in the third quadrant, if you can remember, a sine is negative in that third quadrant. So we should have here negative sine what? Theta. Then the squared is still outside. Okay. Then here for angles that are bigger than 360, that one is a simple procedure of saying you're going to remove 360 from that number until you get a number that is 360 or below, right? So you say 720 minus 360, you get 360. So you're simply going to write it as cos 360 degrees plus theta. Right. Then from there we can say, okay, we do see there is a double angle there. Sine 2 theta is a double angle. And usually when you see sine 2 theta, which is the double angle, we usually just use its formula. Remember that sine 2 theta is equivalent to 2 sine theta cos theta. That is the double angle formula for sine. It's only that one. So it means that we must write it exactly the way it is. Remember that we also have the double angle formula for cos, but there are 3 for cos. You can write it as cos squared theta minus sine squared theta, or you can write it as 2 cos squared theta minus 1, or as 1 minus 2 sine squared theta. Remember that these ones, they are 3. But in this case, we have sine 2 theta. So you're going to rewrite that sine 2 theta as 2 sine theta cos theta. Then you have a sine theta. Now at the bottom, right, you have negative sine theta all squared. Let's remember that the squared means that you are multiplying the bracket by itself once. Like you are saying negative sine theta times negative sine theta, right? And then the 360 plus, let's remember that it is in the first quadrant and cos is positive in the first quadrant, so you simply write cos. Then we can simplify further, right? Say we have 2 sine theta cos theta and then sine theta all divided by right, now you have a sine and a sine times a negative and a negative. What is negative times negative? That is positive. So I can rewrite this as sine theta times what? Sine theta, and then times cos theta. Now one can ask themselves to say, oh, but why didn't we just simply say this will be sine squared theta? Well, it's usually easy to cancel out things when they are in expanded version than when they are in the compressed version. So I am keeping this as sine theta and sine theta. I did multiply them, just that I did not say sine squared theta. I'm just keeping them as sine theta and sine theta. Right, so that I can be able to see which ones can cancel. So here we can see that this sine theta would cancel that sine theta there, and then this cos theta would cancel this cos theta there, and then this sine theta would cancel that sine theta there. Then in that case, the final answer would be 2. Then you are done. So how do we mark, right, to show the mark allocation? Usually, right, for getting this, you would get a mark for simplifying that. And then for using the brackets, good people, here's where you get the mark. You get the mark for the reduction, for reducing the inside part of the bracket. You only get a mark. Remember that I've seen some other students making this mistake, that here they would write that sine squared into 180 plus theta. They just write it as minus sine squared theta. This is very, very wrong, good people. Please do not do that. This is very, very wrong. Don't do that. What I will advise is that take the squared out, reduce inside there, because you're going to get a mark for reducing inside. Then you can do your thing. Then you would also get a mark for this one, right? Then get a mark for expanding the double angle, right? Then get a mark for having this one simplified, and then the final mark would be there, right? Then this is there is another one that we have. This is another one that we have, right? And we are to say for this one now, since it's 4 sine x cos x, you can see, right, there are some things that are going to point you out, guys. You know that the double angle formula for sine, remember we said that it is 2 sine theta cos theta. So if you see something that is sine times cos, remember you can always go back to the double angle. If you are given in an expanded version, you can go back to the compressed version. But how do we do it, right? You see here you have a 4, but we were expecting a what? We were expecting a 2, but instead we have a what? You have a 4. So how do we do it? Well, it's fine. Maybe you can leave it for now. So you can say, okay, it's fine. Maybe let's leave it a bit, right? You know, trigonometry is about strategic thinking, right? It's like playing chess. You think about 4 moves ahead. So, but it's not that difficult. So let's say here you see you have a 2 sine squared x minus 1. What we actually have here is that these things, they look like our double angles, right? Let me just simply take these ones that I had this side, because we are always going to move with them, so let me put them here. Right, when we look at our double angles, can you realize that this part here, whereby you have 2 sine squared x minus 1, looks exactly like, this part, just not exactly, but looks like this part, whereby you have 1 minus 2 sine squared theta. Well, we can just rewrite this part as cos 2x is equal to 1 minus 2 sine squared x. Remember, you can use any letter, any variable that you want, right? So good people, but the problem that I'm having is that the 2 sine squared x is positive, but here it's what? It's negative. The one here is negative, and then here it's what? It's positive. So how do I get it to look exactly like that? I always say, if the signs are the only ones that are different, you have opposite signs, like you are supposed to have a positive, you have a negative, do not worry. What you simply do for me is that you divide everything that you're going to see there by negative 1. So you're going to divide here by negative 1, you divide here by negative 1. What you do on the right, you also do on the left. You divide here by negative 1. And if you do that, you are now going to have negative cos 2x being equal to negative 1 plus what? 2 sine squared x. Now you can see that it looks like this. If you rearrange it, you start with 2 sine squared x minus 1. You will have negative cos 2x here. So you can see, right, that by just dividing by negative 1, you are going to have the same signs. So please make it a habit of dividing by negative 1. But here, because it's an equation, it's much easier to see. I will show you other instances, you know, where you have to use something maybe a bit different. But here, please, let's remember that if the signs are the ones that are not the same, you divide by negative 1. So it means where I see 2 sine squared x minus 1, I can now put negative cos 2x. So here I'll just put negative what? Cos 2x. Perfect. Now remember, here it's 4 sine x cos x, and we needed it to have a 2, isn't it? We needed to have a what? A 2. Trig is all about manipulating until you get something that is exactly like that. So you need a 2 there. So you can rewrite this one. We're going to write it in terms of x. Sine 2x is equal to 2 sine x cos x. Right. But you need a 4 here, right? You need a 4. So for you to get a 4, how can I get a 4, guys? If I have a 2, which number can I multiply by so that I get a 4?
2.
2. Perfect. So if I multiply this side by 2, remember what you do on the right, you also do on the left. I multiply by 2. So that will mean I have 2 sine 2x being equal to what? 4 sine x cos x. Then now it exactly looks like that one. We are just playing on the ones we already know to make them look like what we are given. So now where I see this, I can put this. So I do that here. Now it means for 4 sine x cos x, I can write it as 2 sine 2x divided by negative cos 2x. Perfect. Perfect. That is good. And then now another thing is that we must, I'm going to add it as our additional identity. I'm going to start writing it this side first. Let's understand that tan x will always be equal to sine x over cos x. So even this side, remember tan x is equal to sine x. Please, good people, sine is on top. It's not cos over sine, it's sine over cos. Then let's know that even if you play around with it, even if you have tan 3x, you can write this as what? Sine 3x over what? Cos 3x. If you have tan beta, you can write this as what? Sine beta over cos beta. If you have tan 180 minus x, you can actually rewrite this as sine 180 minus x over cos 180 minus x. If you have tan squared x, you can rewrite this as sine squared x over cos squared x. Cos and sine, they always follow what tan is doing in simple ways. Are we clear? So now that here we have sine 2x and cos 2x, we can actually rewrite that as what? Tan 2x. And then here, remember, there is a 1. So you say 2 divided by negative 1, it's going to be negative 2. So your answer will be this one. So you have simplified it. So let's remember these identities there. I'm going to be going along with them as we are doing more problems, because those are the ones we're always going to use. Right. I'm going to give you 4 minutes to give this one a try. Just 4 minutes to give this one a try. Your time would start now. 4 minutes, guys. The problem necessitates us to use the methods that we have just talked about right now. Okay, so The first thing that we do, we have a cube root outside, and then now you have negative sine 22. All you need is the cast diagram. Remember 0, 90, 180, 270 degrees. And then 360 degrees. Right, and then remember 225 degrees, it is in this quadrant, isn't it? Because it's between 180 and 270. So what you simply do is that you write this as negative, you say sine, and then you would open brackets, right? You say 180 degrees, and then now you're going to say, remember this quadrant is 180 plus theta, right? So you would say plus, how much must I add to get 225? I believe that will be 45, right? 45 degrees. And then you have cos 315, right? 315 is bigger than 270, but is smaller than 360. It means we're in this quadrant of 360 minus theta. So now how much must we subtract? You write it as 360. You write 360. And then you say minus. Then you say how much must I subtract so that I get 315? Right? Usually you can say 360 minus the 315 to actually get that number. You get 45 degrees. So you subtract 45 degrees to get 315. Alright, and then at the bottom here you have sine 120, of which where is 120 degrees? 120 degrees, remember, it's bigger than 90 but smaller than 180. So it's in this second quadrant. And in that quadrant, remember, it's 180 minus theta, right? So we would write 180 degrees minus. Then you say, how much must I subtract to get 120? We subtract 60 degrees, right? Great. Then you have tan 570. 570, remember, it's bigger than 360 degrees. So you simply take your calculator, you say 570 minus 360, you get 210. Now it means you are not going to write 570, but instead you're going to write 210 degrees. And then 300, right? 300 is bigger than 270 but smaller than 360. So it means that 300 is in this quadrant. Remember, that quadrant is 360 degrees minus. But what must you subtract to get 300? You can remove 60 degrees, right? So that's what you would have. And then now that it's like this, good people, already identify the quadrants first. In fact, it's what we missed. We must have started, but I already did it manually. But you must identify the quadrants. Sine 225, remember, we're saying it's in the third quadrant. This one we said it's in the second quadrant. This one we said it is in the first because it's bigger than 360. And then this one is in the fourth quadrant. Great. Then we can simplify and say -2. Now, in the third quadrant, right, of which this is in the third quadrant, is sine positive or negative? Remember, this is your third quadrant, and sine is negative in there, so you have negative sine 45 degrees, right? And then here it's 315, we didn't identify that. It's also in the fourth quadrant, okay? And we know that in the fourth quadrant, cos is what? It's positive, so your answer would be cos 45 degrees divided by sine 180 minus is positive. All right, since it's positive because it's in the second quadrant, so we say positive sine 60 degrees. And then tan 210, remember 210 is bigger than 90. It's also bigger than 180, but it's smaller than 270, so it means that it's between 180 and 270, which is the third quadrant. So this is in the So it means in terms of this one here, we shouldn't write it because we had not reduced it yet. We only write the quadrant for that one once we have reduced. So here we write that it is in there, tan 210, remember, that quadrant. Then now we reduce it according to the third quadrant. We say tan, and then we're going to say 180 degrees plus a certain angle. Alright, what must we add to get 210? Remember, we can add what? 30 degrees. I think it's 30 degrees. Yeah, it should be 30 degrees. And then here in the fourth quadrant, remember cos is positive, so you're going to have yourself cos 60 degrees. Right, quite a lot there, but we are getting there, trust me. Negative times negative, remember that will be positive, so you have 2 sine 45 degrees multiplied by cos 45 degrees, all divided by what? Sine 60 degrees times what? Tan 180 plus 30, and that should be, remember it's the third quadrant, it's positive, so that should be tan 30 degrees, and then multiplied by cos 60 degrees. Now, as you can see, all of those are your special angles, which necessitates your what? Your 1, 1, 2 triangle and your 1, 2, 3 triangle. So your 1, 1, 2 would be this one for 45, and then your 1, 2, 3 triangle, remember the root again, that would be for 30 degrees and 60 degrees. Right, so this is the cube root of 2 sine 45 degrees is what? 45 sine 45 is the opposite over hypotenuse, which is 1 over the root of 2, and then cos 45 is also 1 over the root of 2, and then we divide by sine 60, which is sine 60 is the opposite over the hypotenuse, right? So you're gonna have the root 3 over 2, and then tan 30 is the opposite over the adjacent, so that will be 1 over root 3, and then cos 60 is going to be adjacent over hypotenuse, which is 1 over 2. Good people, once you have this, you put it straight into your calculator to get the final answer. So I think it should be what? Cancel, you have a half, 8 and a half is 4. Is it cube root of 8? Which is 2. Yes, ma'am?
I got it as cube root of 4.
Or cube root of 4, yeah. Cube root of 4. Then you would leave it there. Or you can write it as 2 to the power of 2, and then you write this as 2 to the power of 2 over 3. But leaving it here should give you your full marks. Right, so yeah, I think it should be 4, 8 times half is 4. Yeah, that's true. This guy, the person who made this question, should have said square root to give us a nice answer, but otherwise this is very much, that's what we do. Good people, I always say identifying the quadrants allows you not to make mistake, because you know, after I identify the quadrant, I must ask myself whether that ratio is positive or negative in that quadrant. Next question, guys. A very, very good one. Also, please give it a try. I trust you guys. Give it a try. Or maybe we can actually start by doing it first, and then I'll give you the next one. There are a lot of questions, guys, don't worry. So for the first one, you have sine 180 minus theta, right? Quadrant. Quadrant. So 0, 90, 180, 270, 360. I'm just not supposed to take my Cartesian plane everywhere we go here. But 180 minus should be in this quadrant, so it should be in the second one. 540, that one is bigger, so we shall reduce it first before we can say which quadrant. Right? And then 90 is theta minus 90. We know we know that this one is a co-ratio which should be in a certain quadrant, but I cannot tell which quadrant is it, because now usually, remember, the co-ratios that we have, it's either you have 90 degrees plus theta, or you have 90 degrees minus theta. You understand me? So when it's like this, I have to fix it first before I can identify the quadrant. This one, remember, is a negative angle in the fourth quadrant. This one also, it is in the fourth quadrant. Right, so those two that we need to fix first before we can identify the quadrants. What I usually do, or what I usually say, is that for the fact that I could not identify the quadrant from the get-go, I have to simplify them first. How do we simplify them, good people? I take them out first. I actually say, because I could not identify which quadrant is it in, I'm going to deal with that sine for 540 degrees minus theta. I have to deal with it first. So I say, okay, sine 540 is bigger, right? So you take 540, subtract 360, you get 180. So you actually have sine 180 degrees minus theta. So it's simply saying, instead of writing 540, you're going to write 180. So now that it's like this, I can identify the quadrant, right? Now I know that it is in the second quadrant, and I can actually solve it from the get-go. So this one, since it's in the second quadrant, sine is positive in there, I can simply say this is sine theta already. This is for sine 540 minus theta. Ne? Good. The other one that I couldn't identify which quadrant it was in, it was this one. It was cos theta minus 90 degrees. I couldn't identify because I need to have the angle first. So what I do first is that I rearrange it so that I start with the angle. So I'm going to have cos negative 90 degrees, and then I say plus theta. Right? Negative 90, and then you say plus theta. Now that it would be like this, right, then what do we do? The problem with this, even though we've rearranged it and then we started with the angle, remember you take it along with its sign. That's why I say negative 90. The problem with this is that the angles that we have here, if you can check, all of them, they are positive, right? Even when we're using 180, 360, we use positive 360 minus, or the positive 360 plus theta. We use positive 180 plus theta, or positive 180 minus theta. So we also need to make sure that this guy here is also what? Positive. But how do we do that? Right? It's very, very simple, good people. This is what you simply do for me. You are going to rewrite it as cos, and then you're going to open a big bracket. After opening a big bracket, what you're going to do for me is that you are going to write everything as it is, just to leave a small space. You're going to write everything as it is. So you are going to write negative 90 degrees, then you're going to write plus theta as it is. Then what you're going to do, remember we said, what did we say about changing the sign? we divide by -1, right? So even here you're going to divide by -1. But now it's like we're factorizing. We're actually factorizing. So because you divided by -1, you open a bracket and then you put a -1 outside. That's what you're going to do there. Alright? That's what you're going to do. So you say -90 plus, then you divide by everything by -1, but make sure that you take that -1 out. So that now your answer would be cos negative, then you say 90 degrees minus theta. And you won't make a mistake in terms of the signs. I'm avoiding that. So you should try to always do that. Now that it's like this, it would be very, very easy now, because we take this whole thing here, we take this whole thing as just one angle that has a negative outside. It's almost as if you have cos negative theta. You understand me? Whereby theta would be this whole thing. The negative would be outside. So why am I doing that? Because this allows me to actually say this is in the fourth quadrant. Because all negative angles are in the fourth quadrant. Right. So the answer there would be what? Remember, cos is positive in the fourth quadrant. So your answer for that one would be cos of the angle, right? Remember, cos negative theta is cos theta. So even here we're gonna say cos 90 degrees minus theta. That will be our whole angle. Good people, now that it will be cos 90 minus something, now we can say that that should change to what? To sine theta. Now you can see that, good people, this alone, it had a lot of working out that we need to do. So that's why I don't really do it on the fraction itself. I deal with it separately, then I come back. So don't forget to come back though. Yes, Miss Vanessa?
Say, why is having negative sine theta instead? Like, why can't we factorize negative and then it joins the constant?
Why Resa factorize it negative where?
Yeah, we did factorize negative, right? Why the -1 is a joining the cos outline?
Oh, like why we don't put negative here?
Yeah.
Oh, okay. This is because sine of a negative angle is equal to negative sine theta. Cos of a negative angle, however, how am I writing this? But yeah, it's like that. Negative angle, it's going to be positive cos theta, and then tan of a negative angle is going to be negative tan theta. So I want you to trace this negative to say that negative will only be there, right, if you are dealing with tan and you are dealing with cos. Okay, so for tan and cos, the answer must have a negative, but for cos, it's positive. This is because these negative angles, they are in the fourth quadrant, and if you can remember, in the fourth quadrant, it's only cos that's positive. Yes, ma'am?
You're confusing me now because you said tan and cos instead of tan and sine.
Tan, sine,
Okay.
cos. Yes. Maybe if I can take us back here. Yeah. Do you see here? Can you check in the fourth quadrant which one is positive?
It's cos.
And then sine and tan are?
Negative.
They are negative, right? Right. So let's also check here. Tan and sine, they are what?
Where?
They're negative, right?
Yeah.
And then cos?
Yes. It's positive.
Cos is positive. So in the same way, since we have cos negative of an angle, the answer will be positive cos of that angle.
Okay.
You understand me? So we take the negative angles, these ones, as if they are in the fourth quadrant. All of them.
Alright. Now I get you.
You
Thank
get
you.
me? Okay, perfect. Thank you so much for that. Then from there, right, we are not really done, because now we need to ensure that we finish off with the problem. So what we usually then do is that we go back here and then we say we had sine 180 degrees minus theta times by, remember this one we already reduced it to what? To sine theta. And then the other one we reduced it to sine theta again. So we are already good there. Then at the bottom you have tan, you see, negative theta, and then a squared. Remember, for a squared, what do we do? A big bracket. Then you say sine 360 degrees minus theta, and then you say another, then you say a squared outside. Then now that it would be here, right, now that it would be here, we can then continue with it and then say, obviously guys, when you're writing this part here, you would write it just at the bottom, you know, just that I don't need space. Right, and then you say in the fourth quadrant, in the second quadrant, remember sine is positive, so your answer would be positive sine theta there. Then you have another sine theta, and then you have another sine theta. Interesting. And then here it's tan minus theta. Remember, now it's a negative angle because it's minus an angle. We take them as if they're in the fourth quadrant, and in the fourth quadrant it's only cos which is positive. So the answer here should be negative what? Tan theta. And then after that we then say, since this is sine 360 minus theta, remember that is the fourth quadrant. In the fourth quadrant it's only cos which is positive. So it means your answer there should be what? Negative sine theta. Alright, then what we'll have? Sine theta. Remember, I do not rush to say squared and the likes. I like to keep them like that first. And then at the bottom here you have negative tan theta, right? Now your negative sine squared theta all squared, remember it means the same bracket twice, right? The same bracket twice. And then after that, what do we do? Remember now, since this would be sine theta, and then sine theta you divide by negative tan theta. And then remember, negative times negative is positive. So you essentially have sine theta times what? Times sine theta. Now that will allow me to do what? To say this cancels that, this cancels that. Right. Then I'm left with some interesting ones now, because I'm now allowed to say, since on the top I have sine theta, at the bottom I can write tan as sine theta over cos theta, right, like this. Then good people, what do? We can simplify that one. We have that, right? I want us to know this technique, that we can always use when you have fractions like this, because I find that it's usually, I don't know, should I say difficult? So usually a challenge when people are dealing with fractions like that, ne? So please try to always use this method that I'm gonna show you, if you are able to understand it, but it should be fine. Let me just remove this, ne? Alright, so what you do is that, let me take you back to algebra. Let's say you had x over a over b. Who can tell me what is the answer here? Is it xa? I'm gonna give you options, multiple choice. Is it x? Is it ax over b, or is it x over ab, or is it b over ax, or is it bx over a? Right, between a, b, c and d, who can tell me which one is the correct answer there?
D.
D.
Oh. Which one?
D.
D.
Yeah.
D.
D. Okay. That's true, guys. The answer would be, the correct answer is D. So how do we get D, right? If your denominator is a fraction, please listen carefully. If your denominator is a fraction, what you simply do is that you rewrite that, you leave, the denominator is a fraction, right? You take that denominator out. You're going to take the last denominator out, right? So meaning that you'll be left with x over a, then you multiply by that denominator that is at the last bottom. You multiply by it, then it should give you this answer there, bx over a. We know that in grade 1 we're taught that this thing, how we deal with it is that you would say write it as x divided by a over b, and then after that you would say x times b over a, and then it will be bx over a. But in grade 1 they did not tell us that it's a long method. So a shorter way of dealing with it is that you say the denominator of the denominator, you multiply by it. I know I spoke French. So same thing here. A similar thing is what we're gonna do here. You're going to say the denominator at the bottom, right? You're gonna multiply by it. So you're gonna have sine theta over negative sine theta. Then you're gonna multiply by that bottom denominator, and then your answer would now simply be negative 1 times cos theta. So your answer will be negative cos theta, which will make your life very, very easy. So that's how you'd get your 7 marks there. So let's remember that. I usually like that one, especially for my students whom I know they are also doing physics, you know, and they do Doppler effect there. There's this part where they have, you know, they have this weird denominator over denominator formula, no, numerator, and then the denominator is a fraction, so they usually struggle. So let's remember that. So if you have 2 over x over tan x, how can you deal with this? You can simply say 2 over x, then the one at the bottom, you multiply by it. Okay, then your answer would simply be 2 tan x over x. So let's learn and how to do that. Okay, so let me give you this one to try out, since I've already given you so many techniques. Simplify to a single trigonometric ratio. Only, strictly 6 minutes, guys. right? But remember, when you are done, you just show me with the button and then we're good to go. Get it? Okay, so it says without the use of a calculator we must express it to a single trigonometric ratio there. So what do? First thing, we identify the quadrants. So 90 minus first quadrant, 180 minus second quadrant, this one fourth quadrant, this one third quadrant. Right. Sine 90 minus, remember that 90 minus sine will change to cos, right? So we'll simply have cos x. And then tan 180 minus, in the second quadrant tan is negative, so we simply have negative tan x. Cos negative x, in the fourth quadrant it's only cos positive, so we should have cos x. And then sine 180 plus, remember in the third quadrant sine is negative, so we should have negative sine x. Right, then from there we can see that this one would cancel that one, and then this negative times divide by negative is positive, so we simply have tan x over sine x. Perfect. Now remember, tan we change it to sine over cos. Yeah, this was perfect to have a question like this, ne? Because I know what you did, some of you, right? Or maybe I know what I used to do. Since this is tan, I would write it as sine x over cos x. Then remember it's divided by sine x. Then you know what you're gonna say? Menier said the one at the bottom, we multiply by it. So we must write this as sine x over cos x, and then we say multiply by sine x. Which is very wrong. Which is very, very wrong. Can someone tell me why this is wrong?
Sir,
Mm-hmm.
sir, I think it's because sine x is sine x over 1. So when we multiply, we have to say 1 over sine x.
Okay. Wait a minute. Tell me something. Let me grab the question we had before, and then I want you maybe to tell me what is the difference. When I look at them, what is different? I'm gonna take this, copy, and then I'm gonna put it here. Between this one and this, what is the difference?
Sir,
Mm-hmm.
I think the difference is that for that one with the yellow color, the denominator is a fraction.
Yeah, that is how we can view it. To say the denominator, right? Remember, tan was at the bottom, so it like automatically means the fraction was at the bottom. But here tan is at the top, so it means the numerator is the one that is like the fraction now, if we use brackets. So because of that, we cannot treat them the same way. Rather, what we can rather do, right, is that we can say the whole thing, right, since it's divided by sine x, we can say sine x over cos x. Then change this side now. Use the grade 1 method. Change that to sine x. It's a pain, but yes, it's a pain we have to endure. and then you can write this as sine x now over cos x multiplied now by 1 over sine x. Remember that when you change the division sign to multiplication, you have to make sure that the other side is the reciprocal of that. Then from there you see sine will cancel sine now, then you will have 1 over cos x. Good. Right, I hope we are learning, good people. As you can see, these, like I told you, they come in different ways. So trigonometry needs you to do extra amount of, like a bunch of questions for you to actually come across the situations that you will find in a typical exam. So you need to do a lot and a lot. So there are a lot of ways, but we need to ensure that we keep anything you learn at each stage or each question, you keep and go along with it. I think here now we can simply do this real quick, right, just to ensure that we have covered more. 90 minus first quadrant, 180 minus second quadrant, 180 plus third quadrant, negative x fourth quadrant, right. Sine 90 minus, remember 90 minus, the sign is going to change to cos, so you're going to have cos x. Tan 180 minus, remember in the second quadrant tan is negative, so you're going to have negative tan x. And then in the fourth quadrant cos is positive, so you're going to have cos x. And then this one, oh, it's the same thing. It's the same thing, guys. Okay. No, since we already did it, guys, so this will be negative sine x, and then you know the story, it will be now tan x over sine x, which we can write as tan x divided by sine x, right, of which this would be tan x multiplied by 1 over sine x. Okay, and then remember the tan, you can write it as sine x over cos x. So I try to use a different view there for you to then still see that we get to the same answer. All right. Let me also maybe walk through these due to time, guys, right? Now that you would have this, right, second quadrant, x minus, I can't tell which quadrant is it because it starts with a letter, so I will deal with it first. This one is a squared, it's fine. And then this one I can see is the first quadrant. So it seems like this one I'll have to work on it first. So let's remember, guys, I would write that as cos x minus 360 degrees, right, of which now I would write still as cos, and then remember you divide by negative 1, so you write it as x over negative 1 minus 360 degrees over negative 1, but don't forget to take the negative out. Okay, that negative 1 you also take it out, so that now you can say cos negative 1, and then you're gonna have negative x plus 360 degrees. Then you can rewrite it as what? As 360 degrees minus x. And then now remember, because there is a negative, it's a negative angle, and you know we take negative angles as if they're in the fourth quadrant, and we know that cos is positive in that fourth quadrant, so it's going to be positive cos of the angle. Then still we're in the fourth quadrant, so we're still going to say positive times positive cos x, so it's just simply cos x. So now that we know that it's simply cos x, we can then go back to the question and substitute it in, right? So we are now going to say we have 6 outside, then Sine 180 minus, in the second quadrant sine is positive, so you can have sine x. This one we already reduced it to cos x, and then we divide by sine squared. It's going to be sine squared x minus, now the bigger bracket, remember, it's going to be sine 90 degrees minus x, right? Then the bigger bracket, then we say squared outside. Then this will be 6 sine x cos x divided by sine squared x minus, now sine 90 minus x, right? Remember, sine will change to cos, so you're gonna have cos x because it's a 90 minus, right? Then you're squared there. Then good people, this thing here can be written as what? Can be written as sine squared x minus, now for this one, because there is a minus here, it's fine, we can write it as cos squared x, right? We can write it as cos x times cos x. We start there, cos x times what? Cos x. However, because there is a minus here, remember, if there's a minus or a plus, I'm not going to be able to cancel because there is a minus there. And even if there was a plus, I'm only able to cancel if it was a multiplication sign. So because of that, I have to simplify that part there, right? I have to simplify it to cos squared x, okay, to cos squared x, right? Now that it is like that, what do we do? What can we do there? Let's remember that now this looks, when it's like this, usually it then looks like the identities that we talked about, the double angles, right? So let's remember that a sine 2x is equal to 2 sine x cos x. I'm reminded of this because here I have a sine x times cos x, so it reminds me of this. Now good people, here I have a 6. I need a 6. Remember the last time we had a 4, we multiplied by 2. Now I need a 6. That means I must multiply by 3. Okay, so that I have 3 sine 2x being equal to 6 sine x cos x. Then in that way I know that for the top part, right, for the top part I'm gonna have 3, and then I'm gonna have sine 2x, right, sine 2x. Then I divide. Now I have sine squared x minus cos squared x. This also looks like a double angle formula. If you can remember, we said for cos, right, cos 2x can be written as cos squared x minus sine what? Squared x. You see, this looks very similar to this. What is different? The only thing that is different is that sine here is positive and here is negative. Here this is positive, here this is negative. Then if you can remember what I said we do, I said we divide by a -1 throughout. And when you do that, you're going to have a negative cos 2x being equal to negative cos squared x plus sine squared x. So it means a negative cos 2x would be equal to sine squared x minus cos squared x. Now this and that are exactly the same, so now I can write this. So now I can write that I have negative, and then I write the what? The cos 2x, right? And then good people, just like the previous problem, 3 divided by -1, it's going to be -3, and because it's sine 2x over cos 2x, that can be written as tan 2x. Then you are done, right? Then you are done. Massive. massive. And I hope we are seeing the trend, good people. I hope you can see how we can deal with these things. We must always get that 6 or 7, can even go to 10 marks. Maybe as our This is a very nice question. Yeah, so maybe as our last question for the day, guys, I will leave you to do this one. Yeah. So when it's like this, you know, there's a minus there and then you have a fraction and a fraction. This tells us that actually here we are dealing, we have to remember, we have to like combine the fraction, right? Because it's two fractions. So usually like Miss Ladi said in lower grades, right, we do say cos 33 degrees. We say we multiply the denominators together, right? And then after that, remember, you say this one times that one, meaning you say sine 33 degrees times by cos 99 degrees, and then you say minus cos, or I can still write sine, or it's fine, cos 33 degrees, right? And then you say sine 99 degrees. Right, now when it's like this, it does kind of like looks like something we know. You have sine, cos, cos, sine. If you can remember when we started, I told you that when you have sine, cos, cos, sine, like when you have those expanded versions of the compound angles, then you can know that it relates to one of them. So remember that the one with sine and cos, remember that should be sine, right? Sine A minus B, remember it's going to be sine A cos B, right? And then doesn't change sign, it says minus cos A sine B, right? This is what we have. Now, oh, it actually looks like this. Do you see that? You have sine. I want you to check these parts. You have sine, and then you have sine. You have cos, and then you have cos. Your angle A is 33, right? And then your angle B is 99. So, and then you have cos, right? And then you have sine. And then still it is 33 and 99. So actually we can use the compound angle on top there. We can condense it to say the answer will then be sine 33 degrees, right, minus 99 degrees, all over cos 33 degrees sine 33 degrees, right? Then we can say 33 minus 99, 33 minus 99, that is negative 66, right? So you would have sine negative 66 degrees, all divided by cos 33 degrees sine 33 degrees. Now that it's negative 66, right, what is the, it's, since here you have cos and sine, remember these things, they always lead you to the compound angles. When you have cos times sine, then you should be talking about sine 2 theta, right? Sine 2 theta is equals to 2 sine theta cos what? Cos theta. So if I can write it here, we have on our side, right, we have only cos times sine. By the way, guys, you can write it as sine and cos. So let me write it as sine negative 66 degrees divided by sine 33 degrees times cos 33 degrees. Now I want you to see, now it's the same as that. So the problem is that we don't have a 2 or anything, isn't it? So what we would do is that since we don't have a 2, we can maybe take these 2 to the other side by dividing by 2 both sides. If you divide by 2, you're gonna have sine 2 theta divided by 2. And don't make a mistake of saying 2 divided by 2, please. This angle cannot be divided by anything outside like that. Now this side, if you do that, now you would be left with sine theta over what? Over cos theta. Which means now I can write here that I will have sine 33 degrees cos 33 degrees, and then I should have sine 2 into that 33 degrees divided by 2. So where I see this, I can write that. So now this means I will have sine negative 66 degrees all over sine, remember now 2 times 33 should give you 66 degrees divided by 2. Now guys, you remember it's a denominator, right? So you can write this as sine negative 66 degrees divided by sine 66 degrees, and then the one at the bottom you multiply by it. Now let's remember that sine negative 66, it's a negative angle, it's in the 4th quadrant, so it's only cos which is positive. So this we would write it as negative 66 degrees divided by sine 66 degrees multiplied by 2. Your final answer will be negative 2. Quite beautiful. quite beautiful. Another way, if you didn't want to go this route, there is always another way. There is another way for this one. You could have said, no, when you were at this point, you have sine negative 66 degrees, right? And then at the bottom, you have sine 33 degrees cos 33 degrees. So you could have changed the top part. Remember, it's a negative angle. So you were going to have negative sine 66 degrees over sine 33 degrees cos 33 degrees. Then remember, now you could, sine 66 is a double angle. It's like it's sine 2 into 33 degrees. So you could write it as negative 2 sine 33 degrees cos 33 degrees all divided by sine 33 degrees cos 33 degrees. The bottom part they cancel, and the top one, your answer is negative 2. So you could have done it in either this way or the other way. I think the most important part was to combine these two. If you didn't combine them by multiplying out those fractions, then it would have been a bit difficult. I can't see. Yes, ma'am?
So in terms of proving, do we use the same tools and same methods?
Definitely. We use exactly the same thing. Wanted to show
Can
you.
you do one example of proving?
Yes. Look at this one here. Ne? Let's say you wanted to prove the identity. Let's say you wanted to prove this. Obviously, remember, for identities, we just look at the side with the most information. So in this case, the one that would be with the most information, it would be the left-hand side, which would be cos x over 1 plus sine x, and then plus tan x. Good people, do you still remember we said when we see tan, usually we want to convert it to what? We want to convert it into sine x over cos x. you see here now it's two fractions, just like the last problem we just did right now. We combined them, isn't it? Yes.
So didn't you say it's fine, say.
Okay. All right. So when you combine them, the bottom part, right, usually I say this: if you have a over b plus c over d, the flow of multiplication is like this. You multiply these ones, then you multiply this, right, then you'll end up with that. So you then go to this one, then you go to that one. So this is like the first one, the second one, the third one. So using that, it's exactly what we did on the last problem. So you're gonna have cos x into 1 plus sine x, isn't it? Multiply the denominators. Then you say this times that, right? So that would be cos x times the cos x. Then it will be this times that. So that would be sine x into 1 plus sine x, right? If you simplify it, that would be cos squared x plus, now this one would be sine x, and then plus sine squared x, all divided by cos x into 1 plus sine x. Now the only difference in terms of identities is that in most cases your identities are going to simplify into algebraic expressions, because here you can see, since this is cos squared x and cos squared x and sine squared x, right? Let's remember this identity especially. Remember that sine squared x plus cos squared x is equal to 1. So this one we should always remember in terms of this one. It's another identity on top of the ones we talked about. So when I see cos squared x plus sine squared x there, that should tell me that those ones give us 1, and then you have plus sine x, all divided by cos x into 1 plus sine x. Then these two would cancel, you're left with 1 over cos x. But then I wanted a much more nicer question, but you can see this is the flow, right, that we're using, linking to what we just did. Let me say this one. I hope this one is nicer. Left hand side, you have 2 sine x over 2 into 1 minus cos 2x, right? So what happens there? 2 and 2, can we say they cancel out, right? Or maybe we can, before cancelling out, we can say first of all we have 2 sine x. When we multiply inside, 2 times 1 is 2, and 1 minus, it's fine, we can cancel them out, it's fine. This, let it cancel that, right? Because you don't know where that will lead you. So now you have 1 minus cos 2x. Now if I can take you back again, remember for cos 2x we said it is cos squared x minus sine squared x. We also said it's 2 cos squared x minus 1. We also said it's 1 minus 2 sine squared x. Usually now for identities, you always want to make sure that you try to make them to be one thing. So if on top I have sine, it means I should choose the one that reduces cos 2x to what? To sine. So in that case, I would have sine x over 1 minus into 1 minus 2 sine squared x. Always important to use your bracket. So this is this. Then you have yourself sine x over 1 minus 1 plus 2 sine squared x, right? Now 1 and 1 they cancel, so you simply have sine x over 2 sine squared x, and then therefore 1 can cancel 1 there, so you have 1 over 2 sine x, which is the same as, is it the same as the right hand side?
No.
You have 1 over sine x there. Then in that case, it should be sine, unless if maybe we did something wrong there. 1 minus 2 sine squared x plus 2 no other way, man. It should be like this. It should be 1 over 2 sine x. There must have been some sort of an error here on the right hand side, but I'll check it out for you, but it should be like this. Okay, so in a similar way, we'll still solve this in that way.